Okay, first thing I want to do is investigate the functioning of the op amp, the operational amplifier. And what I have here is the LM741 op amp from Mouser. Let's see here, this is the, I guess, TI op amp. And these are pretty old. They've been said to have, their shortcomings. And this is how IC packages, especially the DIP packages, are often packaged for shipment. You get this nice form-fitted little plastic tube, and then they cut it to size. And to get them out of there, there's a little plastic tab here. Just gotta bend that up so you can open the tube and take one of them out of there. Which can sometimes be a bit of a challenge in its own right. Okay, well, that one don't want to let it go. There we go. So yeah, that's one of the op amps. Just going to go ahead and put the rest of these away. You can just bend that tab back down, that'll hold them in there. See? And if they can put this through the post office, I'm certainly not handling it too roughly. UPS will certainly toss a package around. Alright, so here's our op amp, and what I'm going to do is I'm going to connect it up to a potentiometer. This is a small 50K potentiometer, and I can use that for adjusting the inputs. So first thing I want to do is get this hooked up, so get it jumped across the breadboard. There we go. And the little dot, or the dip, that indicates where your pin 1 is. So for me, pin 1 is up here, up and to the right. So first thing I'm going to want to get connected is the hot and the ground. And I'll use a couple of little jumpers for this. Actually, thinking about it, I want to move this over a little more. Don't want that quite so close to my power regulator because I do want to connect my potentiometer. And let's see here, my inverting input and my non-inverting input, that's going to be pins 2 and 3, so it'll be on that side of the board. So nice little potentiometer I can put on my breadboard. Here we are. Well, let's see here. I actually have that backwards. I believe now I actually have everything backwards, coming to think about it. Because the power rail that I want to use is up here. So yeah, get that on there. And I'll swip this around as well. Yeah, and I'm just going to have to remember how I've, now pin 1 on my op amp is over here. So the reason I've done this is in order to connect my potentiometer. Do a nice job on that. Okay. Let's see, make sure I'm getting it on the pin. And one of those goes to hot, and the other goes to ground. And then the middle pin down here is where I get my reading off this potentiometer. Okay. I can actually test the potentiometer. So let's see, just stick a screwdriver in there. This is the way this one works. You just get a little precision screwdriver and you stick it in there. It's probably not best to just leave it hanging out like that, but oh well. And I'll get my multimeter, and I want to see if you can see. Okay. There we go. Yeah, it looks like you can see the multimeter pretty well there. Can you get a good reading? Yeah, it looks like you can. So, yeah, let's go ahead and check out how the potentiometer is working so we can get an idea on that too. So we kick on our power supply, and right here we can see that the voltage regulator giving us roughly 12 volts right there. So let's take a look at what we are getting across the potentiometer. Let's see, gotta turn my probes around here. So right there we're getting that full 12 volts across the potentiometer. Now, that's with the potentiometer going full off in one direction. So right there, essentially what's happening, the potentiometer is not offering any resistance. And let's turn it. Turn it. Yep. And nothing's happening. Well, why is nothing happening? There's no ground. That's why. Learned that earlier. So, let's take a look at what's happening over on this pin though. See right there on the other side of the potentiometer, it's only got like 5 volts. And let's see here, sometimes trying to figure out how to hold everything is the most challenging part. So yeah, right there we got 5 volts. Oh, look at that, we can drop it. Oh hey, we can cut it all the way off. And move it on up. So we can get up to about half of what the power supply can output with this potentiometer. Okay, because that's acting as a voltage divider. Half of the current is going back to the ground, half the current is going out the middle pin of the potentiometer. So, I want to use that potentiometer to control one of the inputs on the op amp. And what I'm going to do is I'm going to hook that up to the non-inverting input. So, the non-inverting input in this instance is going to be pin 3, which is right here. But I also don't want to necessarily use one of these little buggers because, hey, if I want to rewire something, they're kind of a pain in the butt. So, I'm just going to pull a little piece of wire out, and this is a nice flexible bit of wire I have. It'll stick right into the breadboard, so pin 1, 2, and 3. So that connects my non-inverting input. Now, I want to have my inverting input, in this instance, going to the ground. My inverting input is pin 2, so once again with another little bit of wire, connect that to pin 2, and then connect that to the ground. Now, what I have is on pin 6, so is the output, so 1, 2, 3, so it counts 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6. So pin 6 is up here. That's going to be my output. And just for the sake of simplicity in this instance, I'm just going to send my output. Oh, what can I do with it? Well, in this instance, I'm just going to go ahead and give myself a little contact point. So, that will let me get a reading off the input with the multimeter. And the what's left is to connect the current source and the ground. And let's see here. We're going to put pin 7 is where my power input has to come from. And keep in mind here that I want to use the top rail for my regulated 12 volt power. So 1, 2, 3, 4, 5, 6, 7. So right here, so right next to where we got the output from. And let's see, my pins are kind of bent. And there are various tools I understand that you can buy to straighten these pins back out, but a pair of pliers just works too. There we go. So that connects to pin 7, and then we have to connect to the ground, and the ground is actually pin 4. So right here. Now, to my understanding, what's going to happen is I'm not going to be able to drive the op amp to one rail or the other completely. What I'll be able to do is get it to act a bit as right now it's as a comparator, and that is when the potentiometer is higher than the ground, when what's coming across that yellow wire is higher than the ground, it will cause the op amp to rail high, so basically as high as it can go. And then, of course, when the potentiometer at that point then cuts, when it cuts off, that'll cause the op amp to rail as much as possible to the ground on the output. And then what I'll do here in a moment is I'll hook up some feedback, and then we can see how a voltage follower would work. And that'll also allow me to characterize the voltage following properties of this op amp. Alright. So, now for this, I'm going to go ahead and disconnect my power supply just to make sure I don't, fry out the op amp on the first go off. Okay. So, helps if the wire stays connected. Yeah, these little gator clips suck. I need to find a better way of connecting my power supply. Okay. So, bring the multimeter over. Untangle the wires. And let's see here. So yeah, we're still getting our nice output off of the power supply. And I will stay on the ground here, take a look at what the output on the op amp is doing. And hey, that's pretty nice. It's up at 11.3, so I mean it's decently high there. And let's see here, I might have to find a better ground. Let's try right here. Right there. Okay. Free up my hands. So yeah, that right there, the op amp is at 11.3 volts, so the power supply is just giving us a nick under 12. So that's a decent high value right there. And we're getting that when the voltage coming off the potentiometer, and let's see here, open it up a little bit so I can get the multimeter probe in there. Yeah, so yeah, we're feeding a full 12 volts across the potentiometer, and that's giving us slightly less than 12, slightly less coming out the op amp. So let's rail the potentiometer in the other direction and see what happens. Okay, not a lot going on there. Why? Okay, that's because we're still getting a couple of volts coming off of there. Yeah. Still getting a couple of volts coming off of there. And that, obviously if you're measuring across the ground, you're going to be on the ground. So, that means the op amp is still wanting to be driven high. I believe the solution to that may be a pull-down resistor. So, I'm just going to stick a resistor, let's see, from here to the ground. Okay, and so we add that pull-down resistor, and yeah, that goes down quite a bit instead of being that 2 volts. And now the op amp output, still driven high, could be the value of the resistor or simply where I have it. Alright. Yeah, and that's a little warm. So yeah, I think the lesson in that is what I'm going to end up having to do is using a pull-up, if I want to use the op amp as a comparator in that state, in order to get it to work, I have to pull how do I say this? I have to use a voltage divider network with the output as a pull-up to the inverting input of the op amp to pull that a little off the ground. I don't want that to be exactly on the ground. And then I have to use a pull-down resistor on the output of the potentiometer to drive that nearer the ground. And then that is what will allow me to have a comparator type function going on with the op amp. Now, another thing that we can do with the op amp is seeing about using it as a follower, and the way you do that is you just take the output and you, let's see here, you feed that into the non-inverting, or I'm sorry, you take the output and you feed it into the inverting input, and we can see that right here. Okay, so stick that on there. Now, yeah, I still got that 2 volts there. What's my output doing? Now my output's down a lot. So now my output's down at 3 volts or so. And let's see what happens when I start turning up the potentiometer. Comes up to 5, 6, 7. So yeah, now my potentiometer is controlling the op amp, and it's acting as a voltage follower. And how high can I get that? And I can get that up, just about as high. And then back down to this 2 value, and where's that 2 coming from? Well, these values are actually essentially mirroring what's coming off the potentiometer. And yeah, it seems kind of stupid and pointless doing it that way, but you got to think, more in the long term here. We're looking at a couple of different modes that the potentiometer, that the op amp can function in. And let's throw on this pull-down resistor again. Let's see what's going on now. So Stick that in there. Okay, yeah, so I'm still getting that 2 volts here. And let's see, what about across this resistor? Okay, yeah, nothing going across that resistor. Okay. So it looks like I have successfully gotten that pulled down. Let's turn this up. Hey, there we go. We can get that up to the full 12. Now we can get it to just immediately drop down a lot less than 12. So that's probably not the right value for the resistor to use in there. Let's see. Let's try this other one. Now I can't remember if that potentiometer was open or not. Okay, so yeah, 12 volts across the pull-down resistor. Turn that all the way down. Let's see, and then right off the potentiometer itself, that's about 0.07, right at 0. Turning it up. Get a nice control over the voltage there. And that's coming off the middle pin of the potentiometer. Yeah, it looks like there's a little skip though. Yeah, so we tend to skip 9 and 10. But they are in there. Yeah, a little touchy at that point. Okay. So, let's take that all the way down. And that's indeed at ground. Let's see what we have going on with the op-amp output. The op-amp output is still at about 2 volts there, okay. We'll turn that up. Yeah, there we go. Nice control. All the way up. So hey, we might be able to just throw another pull-down resistor on the output from the op-amp and get all the way down to ground